So we came up with the empirical rule where we said, like, if I go one standard deviation to the left, one standard deviation to the right, we have 68% of the data set. If I go two standard deviation to the left, two standard deviation to the right, now we're gonna have 95% of the data set. And then we went over the last one, which is if I go three standard deviation to the left, three standard deviation to the right, now we're gonna have approximately 99.7%. So the limitation on the empirical rule is that for the empirical rule, unfortunately, like you can't have any like in between. So if we went like 1.567 standard deviation to the right, well, the empirical rule can't really help us with that because the empirical rule only when we go exactly a standard deviation to the left or a standard deviation to the right. So what we're gonna go ahead and do, we're gonna use the normal distribution. And this function, we're gonna use it in our calculator. So we're gonna be using something called the normal distribution. And we're gonna be using this for when our data set is normal. So anytime our data set is normal, and in case you forgot, how does a normal data set look like? It'll look like this. So if our data set is normal, what we're gonna do, we're gonna use the normal distribution. So I'm gonna show you how to get to the normal distribution. So if you look right here, I got a bunch of instruction for you how to go to that on your TI-84. So if you look at step number one, it says choose your distribution. So to choose a distribution, what you wanna do, you wanna hit the second button, and then you wanna hit the bars button. Once you hit second bars, what you wanna do, you wanna select the second option, which is normal CDF, and just press enter. So just make sure the cursor is over normal CDF, and then press enter. Then what you want to do, you want to input normal CDF. So depending on which calculator you have, if you have an older calculator, what's going to happen once you hit enter on the screen or on the main screen, you're going to see normal CDF. And what you have to do, you have to enter the lower bound, you have to enter the upper bound, you have to enter mu, and you have to enter sigma. So the lower bound is just the lowest value that gets shaded. The upper bound is the highest value that you want that's shaded. And lastly, just press enter. And this is how we're gonna get our probability. So one thing you have to be careful because in this section, we're gonna be dealing a lot with infinity or positive infinity and negative infinity. So in our calculator, the calculator actually doesn't have a button for negative infinity and positive infinity. So that's why instead of negative infinity, if you look right here, I say we're gonna use negative 10 to the 10 power. Instead of using positive infinity, we're gonna use 10 to the 10 power. So whenever I mention negative infinity or positive infinity, in your calculator, you're gonna be entering negative 10 to the 10 power and positive 10 to the 10 power. So if I mention negative infinity, we're gonna say negative 10 to the 10 power. If I say positive infinity, we're gonna enter 10 to the 10 power. All right, so those are your instructions so that way you can kind of figure out how to get to the normal distribution. So let's go ahead and do our first example. So for this first example, I already drew it out for you. Okay, if you look right here, it says probability that z is less than 2.33. So we want to find the probability that z is less than 2.33. So what you have to just remember, the middle is always 0, especially when you're dealing with z-score. When you're dealing with z-score, if you remember from last section or last class meeting where we met up on Thursday, anytime we have z value, that means our mu is 0 and our sigma is 1. So that way in the middle of our normal distribution, we'll put 0. All right. So if you look at it right here, I put 2.33. And if you look at this inequality right here, it says less than. So saying z is less than 2.33. So that's why if you look at it, that's why I shaded the left-hand side. All right, so that's my drawing so far. Any question in regard to that drawing? All right, so if you remember when we did the empirical rule, like for the empirical rule, this was literally impossible for us to calculate because we couldn't go 2.33 standard deviation away. So that's why for this one, you have to use the normal distribution, not the empirical rule. All right, so if you remember, anytime we know, so when we have z-score, mu is automatically 0, sigma is automatically 1. So anytime we have z-score, you should already know this, that mu is equal to 0, sigma is equal to 1. Because if you remember on the example we did not yesterday, on Thursday, if you notice, we said that over here too. Mu is equal to 0, sigma is equal to 1 once you find the z-score. So as soon as you know you have a z value, you should already know mu and sigma is equal to 0 and 1.
Trying to take notes, babe. I'm in class. Exactly.
All right, let's mute everybody. All right, so let's go ahead and now we're gonna find out how to enter this into our TI-84. So before we go to the TI-84, I'm gonna just show you how we should enter it. So we're gonna say normal, CDF. So what we wanna do, we wanna find the lower bound, we wanna find the upper bound, we wanna find what mu is, we wanna find what sigma is. So when we're looking for the lower bound, what you're doing, you're looking at the shaded area. So right now, my shaded area is this. So what I'm looking for the lower bound, I'm looking for what's the lowest value that gets shaded. So I'm looking for literally the lowest value that gets shaded. So if there's no cutoff for the lower bound, and it keep on going and going to the left-hand side, well, we're gonna say since you keep going to the left-hand side, theoretically it's going to negative infinity. So if you look at this case scenario, for my lower bound, it doesn't stop. It keep on going and going and going and going theoretically all the way to negative infinity. So that way for my lower bound, we're gonna put negative 10 to the 10 power. And that's your lower bound. For my upper bound, you're now looking for what's the highest value that gets shaded. So you're looking at the right side and you're seeing, does it get cut off? If it get cut off, where does it get cut off at? If you keep on going and going to the right-hand side, that means going to positive infinity. So if you look at this case, it get cut off. So it get cut off at 2.33. So we put our upper bound is at 2.33. So we'll put upper bound right here, or UB. All right. So that's how you figure out the lower bound and my upper bound. Any question in regard to lower bound or upper bound? All right. Up next, we have to figure out what mu and sigma is. So anytime you're given a z value, your mu and sigma will always be the same thing. Mu will be 0. Sigma will be equal to 1. So as soon as you see z right here, that's automatically telling me I have the z value, so mu and sigma will automatically be 0 and 1. All right. Any questions so far? I got normal CDF, negative 10 to the 10 power, comma 2.33, comma 0, comma 1. All right, so let's go to the calculator. All right, so there goes TI-83. So let me turn it on. Let me do some spotlights. So you should be able to see like a green light. Well, not a green light, a red light. So you first hit the second button. Then you want to go right here where it says VARS. And then if you look right here, if you look at option number 2, that's normal CDF. Cool. All right, so let me do that again in case you got lost. So you hit second, you hit VARS, you go right here, number 2, where it says normal CDF. All right. So if you look at my calculator, is a newer calculator, so that why it's prompting me to enter this. They typically call this the wizard, because essentially it's kind of guiding you to tell you what the lower bound, what the upper bound, what your mu, and what your sigma is. So for lower bound, we say it's negative 10 to the 10 power. My upper bound, we say is 2.33. My mu is 0. My sigma is 1. So you go to paste. You press enter. If you have an older calculator, the way yours will show, if you have an older calculator, this is how yours will show. So you would have to put negative 10 to the 10 power. Then make sure you hit the right arrow, press comma, then put 2.33, comma, then put mu, comma, and then put 1, comma. All right, so if you look at it, you get 0.9901. So we get probability that Z is less than 2.33 is equal to 0.9901. And that's how we find the probability for that. Cool. All right, so if you're getting a syntax error, I'm probably like 99% sure. If you're using this button instead of this button below the 3, so you don't want to press, because all right, so instead of using the button for negative below the 3, if you hit the button below the multiplication sign, if you hit subtraction, it will give you a syntax error. So what you want to go ahead and do, you want to hit the button below the 3, the one that said parenthesis, negative, close parenthesis, and then that should give you the correct answer. Or that should give you no syntax error. Any other questions? All right. If you do have the older version of the calculator, so if you have the TI-83 or well, if you have the TI-83, you actually don't have to enter this. So you don't have to enter mu or sigma because that's the default position. So if by any chance you forget to hit mu and sigma, that's okay, because the default position for the normal distribution function in the calculator is that mu is 0, sigma is 1. So if I enter the lower bound, the upper bound, you should get exactly the same answer of 0.9901. Cool. All right. Everybody go for that first example. All right, let's do the second example. So let me venture back to my notes. So let's go ahead and do this one. So this is a find the probability using the Z table. So We're not using the z table, we're using our calculator. So for this one, we want to find the probability that z is greater than or equal to negative 1/3. So if you remember, the middle is always 0. Because if you remember, anytime we have the z value, mu is automatically 0, sigma is automatically equal to 1. Oh, well, let me put sigma is equal to 1. Cool. So if you look at the probability that z is greater than or equal to, the equal sign really doesn't matter, because since we're dealing with continuous data set, it doesn't matter if we include the negative 1.3 or if we don't include it. So the equal sign makes no difference to the question. So it said probability that z is greater than or equal to negative 1.3. So if you look, sorry about that. Here you go, negative 1.3. And if you look at it, I already shaded it to the right-hand side because that would greater than. Because that's what greater than or equal than is for. It's telling us that we want numbers that are bigger than negative 1.3 and equal to negative 1.3. So that's why we shade the right-hand side. So let's go ahead and fill this out. So we're going to say normal CDF of lower bound. So in this case scenario, what would be my lower bound? What's the lowest value that I possibly shaded? Yeah, so we'll say lower bound is negative 1.3. What's my upper bound? What's the highest possible value that I shaded? Cool. So we say upper bound, which is 10 to the 10 power. All right. So we'll leave it at that. So we're going to do normal CDF negative 1.3 is my lower bound, my upper bound 10 to the 10 power. And remember, for this one, mu and sigma, we're going to leave it blank because, well, the default position for the calculator is that mu is 0 and sigma is 1. So why put it twice? So let's go back to the TI-84. So I'm going to go second. I'm going to go to bars. I'm going to do normal CDF. Click OK. If you look at my lower bound, we're going to put negative. So remember, you want to use a negative below the 3. If you use a negative below the x, it's going to mark it as syntax error. So 1.3. Then you do the upper bound. Upper bound should be 10 to the 10 power. And lastly, mu and sigma is 0 and 1. So we'll leave it blank. So you get 0.9032. All right. And that's it for that second problem for the normal distribution. Any question for that normal distribution? All right, back to the notes. All right, so let's try these out. So these are pretty much normal distribution that I haven't shaded in. So we're gonna have to shade it in because in the test or in quizzes, I'm not gonna give you this. Pretty much the only thing I'm gonna give you is this or this. Like I'm not gonna give you pretty much the shaded area. So you do have to kind of figure out how to shade this in properly. So for this one, it says find the probability that z is greater than 2.27. So I'm gonna do this in the left one. So if you look at my z value is 2.27. So 2.27 is probably somewhere over here. If you look at it, it says greater than. Since it says greater than, that means you shade the right side. All right. If you look at that, like we didn't shade that much of it. Like we shade less than 50%. So we should be expecting our answer to be less than 50%. So if you get an answer like more than 50%, you kind of know you did something wrong because that little tail right there shouldn't be anywhere close to 0.50%. Like it probably shouldn't be anywhere close to, it should be close to like what, 20, 10%. So let's do the normal CDF. So first thing we want to do, we want to find the lower bound. So from my drawing, what's the lowest value that I shaded? Cool. You want to check that again, because I'm nowhere near negative 10, well, negative infinity. So if you look right here, I get cut off right here. So that's 2.27. So that's my lower bound. So what's my highest value that I shaded? So what will be my upper bound? Yeah, positive infinity. So 10 to the 10 power. So let's go ahead and do that. So I'm going to do normal CDF 2.27, 10 to the 10 power. So let me go to the TI-84. So we'll go second. We go bars. We do normal CDF. So for this one, all I had to do, change it from 2.27. If you look at my upper bound, well, we already wanted positive infinity, so we'll leave it at that. So we'll go here, paste. If you look at it, the mean and standard deviation automatically is 0 and 1. So if you look at it, the probability that Z is greater than 2.27 is pretty much less than 2%, 0.0116. Oh, geez. We'll put a box. All right, and that's it for that first problem. Any question for that first problem? Let me share. All right, and notice I rounded up to 4 decimal places because usually for probability, we usually just round to 4 decimal places. All right, so let's try doing this next one. So for this next one, we're gonna do it for probability that Z is less than 3.17. So we say probability that Z is less than 3.17. So if you get 3.17, well, it's somewhere over here, 3.17. So if you look at it, it wanted to be less than 3.17. So pretty much want all of this. So if you kind of look at it, we kind of shaded the whole thing. So you should be expecting something near 100%. It's probably not gonna be exactly 100%, but it should be something very close to 100%. So let's go ahead and figure out what is our lower bound, our upper bound, and such and such. So we do normal, CDF. So for this one, what would be my lower bound? What's the lowest value that I possibly shaded when I shaded it all red? Oh yeah, negative infinity. So we get negative infinity, which is negative 10 to the 10 power. What's the highest value that I shaded in red? Yeah, 3.17, good job. All right, so all I'm gonna go ahead and do a normal CDF of negative 10 to the 10 power and my upper bound 3 to the 17. Oh, sorry, 3.17, not 3 to the 17 power. So let's go ahead and transfer back to my TI-84. We go second, we go vars, we go normal CDF. So my lower bound, in this case, we want to change to negative 10 to the 10 power. You want to put upper bound, which is 3.17. You want to put mu and sigma, well, they stay the same, no change there. All right, so if you look at it, we do get something really, really close to 100%. So you get 0.9992. All right, and that's it for the last problem. Any question for the last problem? All right, so up next, we're gonna go ahead and do, we're gonna switch it up a little bit. So what we're gonna go ahead and do, now we're gonna go ahead and do probability. When we don't want just the left side or the right side, we want a middle portion. So for this one, if you look at it, it says find the probability for the probability P of negative 1.57 is less than or equal to Z, which is less than or equal to 0.47. So anytime we have it like this, that means between. So pretty much Z is in between those two values. So that's why if you look at my drawing right here, we have negative 1.57, we have positive 0.47, and you shade the middle portion because we want it to be in between those two values. So anytime I say a number is less than Z, which is less than a other number, it's pretty much telling you find the middle portion. So find the probability of that middle portion occurring. All right. Any question in regard to that first question so far? Great. All right. So for this one, it should be very easy to find the lower bound and the upper bound. Because for this one, you're not going to be dealing with any negative infinity, but you're also not going to be dealing with any positive infinity. Like it should have a cutoff in both ends. So what's my lower bound for this one? All right, so what's my upper bound for this one? Wait. All right, so let's go to the TI-84. Let's enter these values in and let's get our answer. So we go second, we go vars, we go normal CDF. My lower bound is negative 1.577. There you go. My upper bound is 0.47. My mu and sigma stay the same. So you get the probability that's between these two numbers is 0.6226. All right, so that's it for that last one. Any question for that last one? All right, so up next, what I want you to do, I want you to work on the next problem that I have there. Once you're done with that problem, what I want you to do, either private message me the answer, or if you just want to put it in the chat board, yes, enter the answer into the chat board. So try doing this one. It shouldn't take you that very long. All right, so I think I responded to everybody in the chat. All right, so most of you got it correct. So let's go over the answer. So to look at it, you have to go to 2 all the way to 2.17. So we're gonna say that's 2.17. That's 2. So we want the probability of that being in between. So let's go ahead and do this. So for this, we want to do normal CDF. If you look at the lower bound, so the lower part that gets shaded is 2. If you look at the upper bound, the highest value that gets shaded, which is 2.17. So if you kind of look at that slice isn't a really big slice. So we shouldn't really expect that big of a probability. Like you should at least know it shouldn't be like more than 50%, because if it's more than 50%, is all of this. So we kind of know it shouldn't be more than 50%. So if you get something like 50% or higher, you should kind of know something is definitely wrong with your answer. All right, so let's go ahead and do this. Oh no, not Spotify. So let me go ahead and do it here. So we do normal CDF. So you do 2, 2.17, and you get 0.0077. So that's the answer most of you gave me. So congratulations on getting that one correct. So no, not Spotify. So we get our answer to be 0.0077. And that's it for that one. So if you look at, to get these probabilities not that bad, all you have to kind of know how to do is know for the lower bound, the upper bound. If you keep on going to the negative side, if you keep on going to the positive side, you just know that you kind of want to utilize the negative infinity and positive 1. So if you look right here, when you're doing it in the TI-84, you don't have to utilize 0 and 1 because the calculator already knows that's the default position. So if I were to put comma 0, comma 1, it's pretty much useless because the calculator is already assuming that the mean and the standard deviation is respectively 0 and 1. So it doesn't matter if you enter where you say normal CDF of 2 to 2.17, or if you put normal CDF of 2, comma 2.17, comma 0, comma 1. Because for both of them, it'll give you the correct answer because, like I said, the calculator is already going to assume that the default position is 0 and 1. If you want to change that, then that's when you have to actually enter what the new mean and standard deviation is. But if we're going to use the mean of 0, standard deviation of 1, it's kind of like, why bother entering? All right, but that's it for that. So that's how we're going to find the probability for a z value. And this is going to come helpful a little bit later on. But any question on how do we convert a z value and convert that into a probability? All right. And if you need some extra help, or if you need to watch a YouTube video on how to do it, I put a YouTube video up there that says how to convert a z-score to a probability using the normal CDF function on your TI-83 calculator, or 84, whichever one. Cool. All right, so up next, what we're gonna go ahead and do, we're gonna do the opposite. So what we've been doing right now, we've been getting a z value and we've been converting that into a percent. So we started off with a z value, but we ended up with the percentage. What we are now going to be working on with, we're going to be pretty much working backward. We're going to start off with the percent. And what we want to do, we want to end up with the z value. So for this portion, we are going to be working backward. So we're going to start off with the percentage. And what we have to do, we have to find the z value that corresponds with that percentage. So normally the way that work, it will work something like this. It will say probability of Z is greater than A, and it will give us the percentage. So this should be given. And we should be looking for A. All right, so let me go ahead and show you how we're gonna do this in the calculator. So I have the steps right there. So here go the first steps. So the first step, you're gonna hit second bars. Once you hit second bars, what you're gonna do, you're gonna look a function that says inverse norm. It's not actually gonna say that, I gonna say INV, which is inverse, and then it says norm, which is normal distribution. So what we're gonna do, we're gonna choose the inverse norm distribution, and what we're gonna do, you're gonna press enter. Once you hit enter, it's gonna ask you for three things. So the three things it's gonna ask you for is the area, the mu, and the sigma. But just remember for this, mu is 0, sigma is 1. So what we always want to give it, we always want to give it the area to the left-hand side, because the calculator is not that smart. It doesn't know like if you're giving it the area to the right side or the area of the middle. Like it always assuming that you're giving it the area to the left. So if you give it the area to the right side, so say you have something like this, and this is 20%. If you were to enter 20% right there, it will give you the wrong answer, because what it's looking for, or what it understanding, that you want the bottom 20%. So that's how the calculators think about it. So whatever area you give it, and the area always have to be in a decimal, it always have to be the area to the left. So say if I want the 20% to the right, in order for the calculator to give me that right calculation, what I have to do, you have to use the complement rule. So if you think about it, is 20% of the data set is to the right-hand side, you want to figure out how much percent is to the left-hand side. So if I know 20% is on the right-hand side, then to the left-hand side, it should add up to 80%. Because if you look at this area, it should always add up to 1 or 100%. So if the area to the right is 20%, then you should know the area to the left is 80%. And then it will give you this Z value that essentially is cutting off that 80% or the bottom 80% and the top 20%. All right. Everybody go with that? Great. All right, so let's go ahead and do this. So if you look at this next one, it says finding Z when the probability area is known. So we want to find probability Z less than A is equal to 0.05. So sorry, 0.04. So it says you want to find A. So technically there are two ways that you could draw this. Your A could either be over here or your A could be over here. So if this is my A, that means you shade all of this. If this one my A, that means I shade all of this. So which drawing look more correct given that the probability of the left-hand side should equal to 0.04 or 4%? The black drawing or the blue drawing? Here, let's get some more response. Cool. All right, so we got 4 response, 5 response. or remember BL could be black or it could be blue. So for this one, the correct answer should be the blue one. Because the thing is, it should be blue because 4%, if you look at the black one is way more than 4%. Because if you look at it, it crossed the halfway mark. So since it crossed the halfway mark, that means it's more than 50%. So that doesn't really make sense because 0.04 is 4%. So it shouldn't cover more than 50%. If you look at the blue one it's covering less than 5%. So since it's covering less than 5%, well, sorry, since it's covering the left-hand tail and the tail is not going to be more than whatever percentage it is, that's why I know now I know the blue one is correct. So the drawing should look something like that. All right. So since I know A is on the left-hand side, I know this A value should be negative. So when I get my value from the calculator, it's going to give me a negative value. If you get a positive value, you know you did something wrong because it shouldn't be positive, it should be negative. All right, so let's go ahead and find this. So let me transfer over to my TI-84. All right, so we go on, we go second bars. If you look right here, we do inverse norm. So if you look at it, since we want the area to the left to be 0.04, you put 0.04. Mu and sigma, since we're trying to find the z value, you leave mu and sigma alone. You press enter. All right, so we say A is equal to negative 1.7. So we get A is equal to negative 1.751. Everybody good on where does this negative 1.751 come from? All right, so let me go ahead and transfer back. All right. So what I want you to do, I want you to look at this. So this is saying probability that Z is less than A, but I already found out what A is. I found out that A is negative 1.751, which is equal to 0.04. So that's what the Z value should equal to. So Z is less than negative 1.751. You get 0.04. So your final answer should be negative 1.751. So that's how you go backwards. So from an A value to a, well, sorry, that's how you go from a percentage all the way to get a Z value. Any question how I got A is equal to negative 1.751? And also, if you want to kind of double check your answer, it is possible to double check your answer. Because if I want to check to see if that z-score does correspond to that probability, what you could do what we did in the last section, which is use the normal CDF. Because if I use a normal CDF, if you look at this drawing right here, what's my lower bound? Yeah, so negative infinity, so negative 10 to the 10 power. What's my upper bound? Oh. So my lower bound, so if I do normal CDF negative 10 to the 10 power, comma, negative 1.751, it should give me 4% or something pretty close to 4%. So let's see if that's true. So we go second, bars, normal CDF, We go negative 10 to the 10 power. We do upper bound is negative 1.751. 1. You go mu is 0, sigma is 1, paste. You go to enter. And if you look at it, you get 0.03997. So if you look at it, it's a little bit off from 4%, but that's because we rounded off this number because we didn't use the whole z value, because we cut it off from negative 1.751 versus using negative 1.7506867071. If we use the exact value, you should get an answer closer to 4%. But if you look at that, that's pretty close to 4%. So that's what we're doing when we're doing the opposite. You're trying to find what is the z value that corresponds to that value. All right. Any question in regard to that? All right, let's do some more example. All right, so if you look at this one, it says finding z when the probability area is known. So the probability of z is less than a, which is equal to 0.45. So for this one, what do they tell us the percent is? So we know it's 45%, or you do 0.45. Cool. What are we finding? Well, in this case, we're actually finding A, but yeah, it's the z-score. So we're finding z. But technically, we're finding A. All right. So let's see. All right. So if you look at it, we want to find the probability that z is less than a, which is equal to 0.45. And if you look at it, we're shading the left-hand side. So if my probability would have been more than 50%, I'm going to use B. So this is more than 50%. If it's less than 50%, you use A. So that's kind of like an easy trick you're doing, but this only works when Z is less than A. If Z greater than A, you have to use other logic. So in this case scenario, if you're probably less than 45%, we use A. If your probability is greater than 50%, you use B. So for this one, let's use this. All right. So which side of A should I shade? The left side or the right side? Cool. So this is our 0.45. So what we want to do, we want to find what does that A value have to be that cut off the bottom 45% from the top 55%. So if you remember for the calculator always wants the probability to the left side. Well, you shade the left side because the inequality, oops. If you look at the inequality, it says less than. So that way you shade the left-hand side. Right. So up here, we're gonna go ahead and do, we're gonna look for A. So A, in this case, since it's to the left of 0, we should already know A should be negative. So when I do inverse norm, I shall already know for the inverse norm, it should be giving me a negative value. All right, so for inverse norm, what should I say the probability to the left is? So what is the probability to the left? Cool, good job, 0.45. So for this one, you never want to say infinity because technically you don't want your probability to go infinity. It always should be somewhere between 0 and 1. So for this one, we're going to put 0.45. So let's go over to the TI here. So we go second, bars, inverse norm, and you put 0.45, press enter, and you get negative 0.1257. So you get 1250. All right. So if you look at for your Z value, but in this case for your A should equal to negative 0.1257. For that way, you could split up the bottom 45% and the top 55%. So that's the marker that essentially block off the bottom 45% and the top 55%. All right, and that's it for that second problem. Any question for that second problem? Great. All right, so let's do this fun one. So if you look at this one, it says probability that Z is greater than A is equal to 0.10. So if you notice the last two that we did, they were using this symbol. Now what we're doing, we're using this symbol over here, which means greater. Well, greater than. So you do want to pay attention to the symbol because depending on the symbol, it's going to change it up a bit. Because whenever it says less than, you shade the left side. If it says greater than, you shade so you do want to be careful because those inequality will completely change your problem for you. So when we're doing this, same thing as before, it could either be A or it could be B. So you can either shade the Z value on the negative side or it could be a Z value on the positive side. So the way I determine to see which of these two Z value I want to use, you have to look at the probability. So for this one, what's my probability? Cool. So probability 0.10. So you have to go, does this look like 0.10? Or does this look like 0.10? Which one looks more realistic that it will contain 10%? Would A be more realistic or B be more realistic? So it should be B. B is more realistic, so we're gonna go for B. All right, so let's do inverse norm. So I wanna do inverse norm. What should I tell it is the probability to the left-hand side? Oh, good job. So you have to remember, whenever you're doing the Z-score never wants the probability of the right side. It always wants the probability of the left side. So if the right side is 0.10, that means the probability of the left side is 0.90. Because if I do 1 minus 0.10, you get 0.90. So once again, the complementary rule is coming into play. So if you didn't understand the complementary rule before, you do kind of want to get this down locked for these type of problems, because it will help you out. All right, so we get inverse norm of 0.90. All right, so for the B value, well, here, let me change that to A. I don't want to get it confusing because we're solving for A. So for this A value, should I expect a negative value or should I expect a positive value once I hit inverse norm 0.90? Positive. So we know it should be positive because it's on the right-hand side. So since it's on the right-hand side, we should get a positive. So let's do inverse norm 0.90. All right, so you have to make this easier. You want to press second, enter, and then you put 0.90. So if you look at it, I get 1.2A16. So, yeah. So that's your answer. So your final answer should be A is equal to 1.2816. So that's the Z value that break up the top 10% and the bottom 90%. Any question on how I got the answer? So let's see what happens. So say if we have made a mistake and we didn't do the complement rule where we said 1 minus 0.10, we got 0.90. Say we just put 0.10 and we get this. What's the difference between inverse norm 0.90 and inverse norm 0.10? I'll get with the 1 in. So if you look at it, the only difference is the positive 1.2a and the other one is negative 1.2a. So, because the thing is, if you remember, this is the normal distribution. The normal distribution is symmetrical. So it doesn't really matter if you want the bottom 10% or the top 10%. The cutoff for the Z value is still the same. The only thing different, if it's on the left-hand side, it's negative 1.2a. If it is on the right side, it's positive 1.2a. All right. All right, and that's it for that one. So the way that you want to write the answer, well, it would be A is equal to 1.2A16. And just depending on how many decimal places I want, you just adjust based off how many decimal places I want. But technically the answer would be that. It would just be 1.2A16 when you enter it. You don't really want to enter A is equal to that. You put 1.2816. All right. Any question for that last one?
What do you enter for the norm CDF then, in this case, if you want to test it out?
If you wanted to check your answer to make sure it's correct,
Yeah.
so I'll put right here to check answer. You want to do normal CDF. And then if you look at it, pretty much this is the cutoff. So it'll be 1.2816. So it depends if you want the probability of the red or if you want the probability of the black. I'm going to get the probability of the black. So if you look at the black area that I shaded, the lowest point or the lower bound will be 1.2816. If you look at my upper bound for the black, the upper bound keep going to the right hand side. So technically it's 10 to the 10 power. So if you were to do normal CDF 1.2816, comma 10 to the 10 power, it should give you a probability close to 0.10. And here, let me just double check that. So second bar, normal CDF, 1.28, here, I forgot that answer. 16, comma 10 to the 10 power. And if you look at it, you get 0.09999. So it's telling us it's really, really close to 10%.
Oh, okay.
All
Okay.
right.
Thank you.
All right, let's do the second one. All right, so if you look at the second one is saying less than. Here, let me pick this up. All right, so if you look at the second one, the symbol is saying probably the Z is less than A. So this one, remember, you have to shade the left-hand side because we're using the less than symbol. So it's saying probably the Z is less than A is equal to 0.95. So we have two options. So one of the options is we could say A is over here. That look more like a 9. We could say A is over here. And we could say that this is 0.95. Or the other option we could say A is over here. But now we can say from here to here, this is 0.95. So which of these two options look more realistic, the red option or the blue option? All right, so the blue option should be more realistic because it doesn't really make sense that we have 95% in that little tail when I know from the end of the tail to the middle is 50%. So you go like, how can you jam 95% in when 50% is less than that? So I know this should make no sense. So we want this over here. And this should be 0.95. All right. So what we're going to go ahead and do, we're going to go ahead and do inverse norm. Cool. Remember, we want the area to the left. So the area to the left is the blue area. So what should I put for the area? So you put 0.95. So we're going to do inverse norm of 0.95. Also, you should know that A, since A on the right-hand side of 0, A should be a positive number. So let's go ahead and see if everything checks out. So we're going to go ahead and do, we're going to go second, bars. I'm going to go option number 3. I'm going to say my area is 0.95. We go paste, 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 paste. Go to paste. So if you look at it, we get A is equal to 1.64, we'll say 49. So if you look at it, we get 1.6449. And that's your final answer. All right, so let me just show you what I got or how I put the final answer. For that way you kind of know for a test or for a quiz how I want the answer. But also depending on how many decimal places I want. All right, so we say A is equal to 1.6449. And that's your final answer for that one. Any question for this last one? All right, so let's go ahead and do this next one. So for this one, we're going to say probably that Z is greater than A is equal to 0.67. So if you look right here, it says find A. So what we have to do, we have to find the Z value that correspond to this 0.67. So remember, there are two options that we could do. We could either say A is over here, and we could say this is 0.67, or we could say, let me get a different color, or we could say A is over here, and we could say this is 0.67. So which one looked more realistic? The green one to be 0.67 or the blue one to be 0.67? All right, so for this one, you do want to say the green one, because remember, from the middle to here, that's 50%. So if you go from the middle to the end, if that's 50%, you go like, how come this portion right here be more than 50%. It doesn't make sense. So that why for this one, you do want to choose blue. Oh, sorry, red, green. You do want to choose green. So for this one, we're going to do inverse norm. And for this one, what should I put for the area for inverse norm? Oh, 0.33. Yeah. Remember, for the calculator, you always want the area to the left. So you want to do 1 minus 0.67, which is 0.33. Unless you have like the newer TI-80, I don't even know what they call it. If you have the newer TI-84s, they actually let you choose the left side, right side, or center. So if you do have the new one, you actually have that option. But if you have the TI-84 plus and down, you don't have those options. All right, so we're gonna do inverse norm 0.33. So let's do second bars inverse norm 0.33. All right, so if you're looking for an answer, we get negative 0.4399. So you get A is equal to 0.4399. Make sure you put the negative. All right, so for this one, A is equal to negative 0.4399. There's some people asking in the chat, how come for the last one I didn't do it? Well, for the last one, if you look at it, we have the less than symbol. So when we have the left-hand symbol, whatever the probability is here, you put that probability in here. But if you look at this one says greater than. So for this one, you have to do 1 minus the 0.67. So if you kind of want to know or have like a little formula going, if you should say like if it says Z is less than, just use the probability inverse norm. If it says Z is greater than A, then you have to do the complementary rule for that one. So that's kind of like an easy way to kind of think about it. All right, so what I want you to do, I want you to practice on these. How many do I have here? So I want you to practice on these two. So once you get the answer, you can either private message me your answer, or if you just want to put it in the chat, you just put it in the chat for that way you can see if you got it right. But you do want to practice on this because, like I said, practice makes perfect. You can't really just watch me do it because I'm not going to do it for the test. You're going to be the one doing the test. So practice on it for that way you can get comfortable with your calculator. For that way, well, you know how to use your calculator. So try A and B. Like technically A, we already did A. All right, so let's try doing this one. Yeah, right of 0. So if you look at probability of z less than a, which is equal to 0.15. So one thing you have to just know, it says less than. So the less than means you're shading the left-hand side. So for this one, it should be this. So for this one, you just want to do inverse norm of that probability. So some of you already gave me the answer. So A should be negative 1.282. If you also look at this one technically we already did it, because if you remember, we said we wanted the top 10%. So the top 10% is the same thing as the bottom 10%. It's still going to be 1.282. The only thing different for the bottom 10%, which this one is negative. If we wanted the top 10%, it's going to be positive. All right, so for B, if you look at it, it says greater than. Greater than means you shade the right-hand side. For this one, you want to do inverse norm, and you do 1 minus the 0.30. Because if this is 0.30, let me use a different color. This has to be 0.70. So remember, the calculator always wants the probability of the left-hand side. So we have to take the complement of 0.30. That's why we use 0.70. And if you do that, you should get A is equal to 0.5244. All right, and that's it for B. Any question in regard to B? Good. All right, let's move on. All right, so now we're gonna move on where we want to find the percentage in the middle. But what I want it to be the percentage in the middle where two z values that are exactly the same number. The only thing different, one of them is negative, one of them positive. We want those two z values to capture that percentage in the middle. So we have the percentage here. And then what we do, we want two z value that capture that percentage in the middle. And the only thing that should be different of the two z value is that one of them is negative, one of them is positive. And you could technically do that because remember, the normal distribution is symmetrical. So what we're gonna do, we're gonna start doing this. So we're gonna start finding what does the b value has to be in order to capture the percentage in the middle. So for this one, we're not getting the percentage to the left or the percentage to the right. We're getting the percentage in the middle. So let's go ahead and find this example. So I gave you a formula here. So that's the formula. You could use that formula, or what you want to do, you kind of want to just use your logic. So I'm going to show you how to deal with the formula and then how to do it using logic. So let's do the first example. So it says find B for the middle 95%, or B is, or sorry, the probability that negative B is less than Z, which is less than B, which is equal to 0.95. So this is telling you want the middle. So we're gonna say this is the middle. So we say this is negative B, this is positive B. So if that's the middle, you want the middle percentage to be 95%. So we have 95% there. All right. Everybody good? Why I placed the 0.95 in the middle? So up next, what I'm gonna go ahead and do, I'm gonna find these percentage here. So to find those percentage, the way I want to find those percentage is by using this formula. So you're gonna say 1 minus the percent. So the percent of this one is 95%. So we write it as 95% divided by 100. Divide that by 2. So if you do 95% divided by 100, what's 95 divided by 100? Oh, 0.95. So you do 1 minus 0.95 divided by 2. What's 1 minus 0.95? Want to check that again. That's 50%. There you go. The 0.05. And lastly, what's 0.05 divided by 2? 0.025. So you go, this is 0.025. This is 0.025. So if you look at it, if I do 0.025 plus 0.95 plus 0.025, it add up to 1 now. All right. Everybody good on the 0.025? Where does it come from? All right. So if you remember from the calculator always wants the probability to the left. So the easiest way to do it, give it this probability over here. So we're gonna say inverse norm of 0.025. Yeah, for if you want to use that formula, you want to convert the decimal into a fraction. That's why you do 95 divided by 100 to make it into a fraction. All right, so let's do inverse norm 0.025. So let's go ahead and do that on the TI-84. There we go. Second, bars, inverse norm. So we do 0.025. You leave everything as is. All right. So if you look at it, you get negative 1.95996. But if you actually just do the rounding, so if I try rounding it off to 4 decimal places, there's kind of like a trickle down effect where everything keep on getting rounded off. So for this one, you actually get negative 1.96. And somebody had mentioned earlier from -2 standard deviation to 2 standard deviation, it was 95%, kind of going back to the empirical rule. So the empirical rule is kind of slightly off. So that's why we're like, once you actually know the z-score or know how to find the z value that corresponds to a percentage, you kind of want to use the z-score because the z-score is more accurate versus the empirical rule, where the empirical rule is not that accurate as a z-score. So if you look at it, we get negative 1.96. Any question on how we get negative 1.96? All right, so let me go ahead and grab some answer. All right, so if you look at right here, for this b or negative b, we put negative 1.96. For this one, we put positive 1.96. So what this is saying, from negative 1.96 all the way from positive 1.96, if we find the probability in between, that should add up to approximately 95%. Yeah, like I'll tell you how many decimal places to use. So if you were to do normal CDF and do normal CDF of negative 1.96 all the way to positive 1.96, like you're gonna get something very close to 95%. So that's what this is doing. You're getting 2 z values that are identical. The only thing different, one of them negative, one of them positive. That's capturing that percentage in the middle. All right. Everybody good with that so far? And for this one, for your final answer will be B is equal to 1.96. Anytime you're doing this one, when you're finding the Z value that correspond to the probability in between, your Z value, I always want the positive one. I don't want the negative one. To kind of think about it, because right here, it already has a negative, so you put negative B. Here's positive B. So for this one, your value that you find, always give me the positive value. Never give me the negative value. All right, but that's it for that first version. So for that first version, I used this formula up here. For the second example, I'm not going to use a formula. I'm just going to kind of use logic. So let's do the second one. So for this one, the probability that negative b is less than z, which is less than b, is equal to 0.80. All right. So what percentage should I put in the middle? So 80. So we put 0.80. All right, good job. So we're not going to use the formula because you could kind of just use logic. So if I know 80% is in the middle, how much percent is left over out of the 100? 20. So you have 20% to fill this one and to fill this one. But the thing is, so you have this 20% and you want to evenly fill out both tails. So essentially, yeah, like Raimundo say, what you want to do, get that 20% and evenly break it up. So what's going to happen, you could do 20 or 0.20 divided by 2 and you get 0.10. So here 0.10, here's 0.10. And that's how you want to do it, kind of just using logic. Okay, you go like, I already know there's 80% in the middle. So if they're 80% in the middle, that means there should be 10% to the left, 10% to the right. All right. Everybody good on how I got 0.10, 0.10? All right. So anytime we're doing these type of problem, just find this value. So we're going to do inverse norm. And what should I say the area? 0.10. All right, so let's do inverse norm of 0.10. So we go second vars, inverse norm, 0.10. All right, we get negative 1.2816. If you look at this one should look familiar. We already did this one before. All right, so we get inverse norm of 0.10 is equal to negative 1.2816. So that means B is equal to positive 1.2816. And that's your final answer for that one. So just remember for this one, these values should always be positive. So if I'm telling you to find B for in between, this B value should always be positive. All right, so up next, what I want you to do, I want you to try this next problem. So I want you to find probability of negative B is less than Z, which is less than B, and it should equal to 0.60. So take a minute, try doing that. If you want to ask me a question or if you want to double check your answer, either put it on the chat or you can just private message me and I'll let you know if you got it correct. Alright, so most of you already did this one. So pretty much what you should have done, the middle is 60%. So if the middle is 60%, so that means there's 40% left over. If there's 40% left over, you want to evenly break that out into the both halves. So pretty much what you want to do, say 20%, 20%. So if you remember, you always want to just use this one. So we're going to say inverse norm of 0.20. So if I do inverse norm of 0.20, I already did it. You get negative 0.8416. So that means B is equal to positive 0.8416. And that will be it for that last example. All right. Everybody good for those last examples? Great. All right, so we're gonna go ahead and do, we're actually gonna stop here. I don't wanna really overwhelm you. So I do wanna let you know for tomorrow, you are gonna have a quiz, and the quiz is pretty much just gonna cover this. So you just know how to do normal distribution on your calculator. You just know how to do the inverse norm. And that's why, if you know how to do those, they should be pretty simple. If you looked at this, like none of these problems took that much effort to do. So I'm gonna give you, I think, 20 minutes to be able to do this quiz. So that should be more than enough because there's only gonna be 5 questions. And pretty much all of them is just whether you know how to do inverse norm or the normal distribution or normal CDF. All right. Any question in regard to what we just did? Go. What's your question about the task? Yeah, I'll upload this video as soon as I can, because I first have to buffer it, and then I have to just upload it to YouTube, and then just do something else. Yeah, I'll upload the notes as well right now. Let's see. Let's see. Let's see.